And welcome back, and it is the 15th of May, higher plus 5 a day. And let's have a look at the first question. Right, so the first question says, the diagram shows the circle x squared plus y squared equals 17. I won't write on it yet, let's see what it wants me to do. The point P lies on the circle and has a coordinate 1. Actually, I said I won't write on it, I'm going to write on this, so 1 something. The tangent at the point P crosses the x-axis as R, okay? Work out the coordinates of the point R. Wow, right. This is where I pause for a second to think about it. Well, let's start with the obvious point. So the radius is root 17. It tells me that in the question. I also know that the p-value, actually, I think I'm just going to do the sort of classic MR thing, aren't I? All right, okay. Let's first of all look at the point P. Let's explain what I mean by that. So if I consider the point P, I know that x equals 1. So when I have x squared plus y squared equals 17, well, if x equals 1, that's 1 plus y squared equals 17, which means that y is the square root of 16, which is plus or minus 4. Now, by looking at what's called by inspection, by looking at the diagram, I know y is positive, so therefore y is 4, which means that p is equal to 1, 4. So I've got my first piece of information. I've worked out that p is 1, 4, which means I can do the thing we've done a few times, which I can work out the gradient of the radius, because it goes up 4 and across 1, so it's 4, which means I can work out the gradient of the tangent, which is the line PR, which is going to be minus a quarter. And I know the equation of the tangent is going to be y equals minus a quarter x plus c, where I'm going to use the p point, 1, 4. So that's going to tell me that 4 is equal to minus a quarter plus c, which means that c equals 17 over 4, which means the equation of my tangent is y is equal to minus a quarter x plus 17 over 4. And what do I want to do? I want to find out the coordinates of point R. Well, that's where y equals 0. So in other words, it's saying to me, where does y equal 0? So I want y equals 0. So in other words, 0 is equal to minus a quarter times x that I don't know, plus 17 over 4. Therefore, a quarter x equals 17 over 4, which means that x equals, multiply both sides by 4, which means that x is equal to 17. So let's answer the question. The question says, what are the coordinates of r? So r is equal to 17, 0. That is actually quite a difficult question. It's a good question. You know what I'm going to say next. I like that question. Next question. Find the volume of the liquid in the container. Now, this is actually quite a clever frustrum question, isn't it? And the way I'm going to do this is I'm going to find the volume of the whole container. So I'm going to call that a large one. And then I'm going to take away the volume of the small container, which is the one at the top that's going away. And that's going to leave me with just the liquid at the bottom. So I'm going to need some measurements first, aren't I? So let's zoom in first of all. So let's draw a line straight down. And this line then goes across. So I'm creating a triangle. Now, the reason I'm doing that is because in order to work out areas of cones or volumes of cones, I need the radii. So for the large one, I know the radius is 14, divided by 2, which is 7. So sorry, the radius is 7, and I know the height is 20. For the small one, I know, well, it's going to be slightly tricky, isn't it? So I know, he says, thinking about it, so I know the height is 8, because it's 12 minus that. So I know the height's 8. Now, if the height is 8, the scale factor to get from the large one to the small one is to multiply by 8 over 20, which is the same as, well, divide by 4, so 2 over 5. So therefore, my radius, this isn't a nice number, isn't it? So my radius is 7 times 2 over 5, which is 14 over 5. It's actually quite a clever similar shapes question. Now, talking of which, actually, what I could do is work out the volume of the whole cone and then just use similar shapes, volumes, to actually do it slightly easier. But I've gone down this route. I'm going to carry on down this route. Now, importantly, let's write it in, and then I can show you. I've got the radius and the height of the small one, the small cone at the top that's going away. I've got the radius and the height of the overall cone, which means in one equation, I can say the amount of water is the amount of water in the whole cone, or the volume of the whole cone. So that's going to be pi over 3. So it's a third of pi times the radius squared times the height. And then I'm going to take away pi over 3 times 14 over 5 squared, so the radius squared, times the height, which is 8. all that in my calculator in one go. And that tells me it's 960.573, etc. So I'm going to say 960.6 centimeters cubed. Now, as I was midway through that question, I realized there's probably a quicker, cleverer way of doing it, isn't it? So I'm going to show you the other way, and I'm going to show you that arguably that's a little bit easier. So what I'm going to do here is I'm going to go back to two numbers that I said. So let's consider, what shall I do? So let's consider the height of the small cone, which is 8, and the height of the big cone, which is 20. So I know the length scale factor to get from large to small. So the length scale factor from large to small is times by 8 over 20, which is 2 over 5, which means the volume scale factor is a cube of that. So that is times by 8 over 125, which means I could work out the volume of the big cone. So the volume of the big cone is going to be a third times pi times 7 squared times 20. And then I can work out the volume of the small cone by multiplying that by 8 over 125. So in other words, I can do two cones. So if we do the first one, so in other words, the volume of the big cone, that is 1026.25. And then if I multiply that number by 8 over 125, in other words, the volume scale factor, that is 65.68. And then if I take that away, perhaps unsurprisingly, I get 960.57, but we'll call that 960.6, which is the same. So two different ways of doing the same question. I think the second way would be hard for most people to spot. They're expecting you to work out the volume with two different cones. Either way, good, tough question. Next question, what do we have? We have two more to go. Prove that the angle in a semicircle is always 90. Now, if you've seen my videos before, I'm not going to write a huge amount here. I'm going to talk to it and say the important words. Otherwise, you just watch me write an essay. The way you're going to do this is you're going to set up a radius in the middle. And you're going to acknowledge that these two lines are the same, which are the same as these two lines here. Then you're going to say, so you're going to write something down like angle OAB is equal to X. And angle, what should we say, OCB is equal to Y. Then you're going to make an argument that because of isosceles triangles, this is also equal to X, and this is also equal to Y. Therefore, if I consider the triangle ABC, so for triangle ABC, it must be the case that all the angles, so X plus Y is equal to 180, which is the same as 2X plus Y is equal to 180, which means that X plus Y is equal to 90, and you have proven, because that's X plus Y, you have proven it's a right angle. I don't think those questions should come up, but they might do. But either way, it's worth making sure you've kind of understood the idea. Good question. Next question and final question today. All values are correct to 2 sig fig. Calculate the upper bound. Oh God, here we go. Upper bound. I hate bounds. Upper bound of AC. Now, not that you're not doing this anyway, but I would definitely say pause the video, have a go at this question before I've done it, because I know what's going to happen here, and there's a bit of a trap that you need not to fall into. So pause the video, try the question, and then watch me do it. Okay, so hopefully you had to go first. So it says all values correct to 2 sig fig. So I'm going to note that the 25 degrees to 2 sig fig is 26 and 24. And then I'm going to note that the 14 centimeters to 2 sig fig is 15 and 13. I'm not calculating the numbers I need yet, and you'll see why in a second. And the 140 degrees is to 2 sig fig 150 degrees or 130 degrees. And that, by the way, is not the catch I'm talking about. Then it says, calculate the upper bound of AC. So AC is opposite 140. So AC over, I'm going to write 140, but I'll use the bound in a second. So AC over sine 140 is equal to 14 over sine 25. Which means the formula that I need is going to be AC is equal to 14 times sine 140 divided by sine of 25. Now, I need to think carefully about whether I want this to be an upper number or lower. I want the upper bound of AC. So in other words, I want this to be as big as possible. I want this to be as big as possible, but the way I make sine 140 bigger is by making it a smaller angle. So I'm going to actually use the smallest angle here. And the reason for that, by the way, is because the sine curve does this. After 90, the more I go this way, the smaller the value of sine 140 is. Again, have a play with that, make sure you're okay with that. It's a clever little question. On the other side, sine of 25, the more I go up, the bigger the value is. Now, because I want AC to be as big as possible, I'm therefore going to take the smallest value of 25. So when I pull all this together, that is the same as saying I want the upper, so that's going to be 14.5, times by sine of the lower, which is 135. And I'm going to divide all of that by sine of the lower, which is 24.5. And I'm going to put all that in my calculator, and I get 24.7244162. Now, it doesn't tell me how many sig figs, so I'm just going to write all that down. So 24.7244162. And if you got that, by the way, well done. I think that is one of those really sneaky little tricky questions that is a lot harder than it looks. Good day today. I really like all the questions today for different reasons. So hopefully you got all those as well. Do let me know if any of those you want me to go into a bit further. Do make sure you understand your proofs. Again, it's unlikely to come up. And like I said, that last question was really quite tricky. A really good question at the end. Like, subscribe. See you tomorrow.